All right, so let's get going. Hello everyone and welcome to this day of MARC seminars. So I'm very happy. I'm Thomas Nolte, I'm the director of MARC, and today I have the pleasure of presenting to you two very nice seminars that are given by well-known professors in the community. And first out, I'm happy to introduce Professor Thilo Sauter from TU Vienna and also the University of Graz. Short words about Thilo. You have the nice bio in the call for this, so you can read the details, but I must say I'm very happy to have Thilo here. He's one of the key central people in the IEEE Industrial Electronics Society, in particular the Technical Committee on Factory Automation, but also other things. And not only working for the IEEE technical committees and so on, Thilo has also in parallel with the research been very active with work on standardization for industry. So please, Thilo, I give the word to you and give us this nice presentation. And thank you.
Okay, thank you, Thomas. Thank you for inviting me. Thank you for the introduction. I will try to stick to the 40 minutes that I got, or 45. We are real-time people, so we know how to deal or not to deal with deadlines. Yeah, not too much about real-time today. It's more about safety and security in industrial automation and why we should actually have a holistic view on that. Now, yeah, automation is getting more and more vulnerable. You know it, of course. Yeah? When we look back, Stuxnet was maybe the first time that most of us realized that automation systems can be attacked by cyber attacks. But there have been lots of attacks since then. 10 years ago, Stuxnet was 15 years ago already. It seems still like yesterday, to me at least, maybe to some of you too. 10 years ago, there were attacks on the Ukrainian power supply system. A colleague of mine, who is now at TU Delft, actually happened to be there. They were doing a project with a power system operators, and all of a sudden they witnessed when something strange was going on the screens, and they saw arrows moving around, and obviously people from outside trying to hack into the system. And this has increased in the recent years. Many of these attacks recently are actually ransomware, so people are just exploiting vulnerabilities of operating systems and just shut down the systems and then ask for a ransom in order to make systems available again, or maybe not available again, who knows. So some of the attackers are just criminals, cyber criminals. Other attackers are actually state actors. So behind many of these attacks seem to be people who are actually sponsored and supported by governments, which means that they have unlimited resources, they have lots of time to set up these attacks, they have lots of money and also computational power. Now, that's just to set the stage. I want to talk a little bit about communication in automation, of course, then safety and security, and why they are important and what has been done in the past regarding standardization, and then how everything fits together and why everything is somehow mutual dependent. And then I would like to tell you just very briefly what we have been doing in the past 5 years in that area in a large research collaboration with TUEV Austria. Now, okay, why do we have all these attacks these days? Well, it's because the communication systems that have been introduced in automation for a long time, we have somewhere.
Sorry.
Okay, there was an echo. Can you hear me? Echo. it's the communication, right? We all know the automation pyramid that connects the field devices with the PLCs, with the SCADA systems, with the data centers that actually are used to analyze the data and to steer the processes. We are connecting IT systems to, well, what was called automation systems or filter systems in the past. Nowadays we are talking about operational technology, OT, which is a way cooler way of expressing it. But essentially this dates back to the 1980s, 1990s. And with all of this, our systems become more interconnected, and of course they become more accessible from the outside. And it's getting even more complex. If we look at the ecosystem today, we still see some traces of the automation pyramid. So we still have this OT systems on the back, on the bottom. We still have the IT systems, MES and ERP systems on the top of the pyramid, but it's getting extended. So part of the functionalities nowadays actually provided in a form of cloud services. Automation as a service is a fairly new topic. We extend the field layer to the edges by including mobile devices, by including mobile networks. We are connecting enterprises along the value chain with some cloud-based systems because it's convenient, it's modern, and these are still private installations mostly. And if we want, we can also connect it somehow to the public cloud. And all of that makes everything much more interconnected and, of course, much more accessible. So down there, it's still operational technology, and the upper layers are classical IT systems. Okay, now talking about safety. Safety has been a topic in industrial automation for decades, actually for more than a century. It started all with the protection of workers and the environment. The safety of steam vessels actually stood at the beginning of TUEV. They were founded as an organization to check if steam vessels are really safe from an operational viewpoint. And electrical safety was the starting point for associations like the VDE in Germany or ÖVE in Austria. So all of these associations originally started from the safety aspect and from the safety considerations in order to make the use of electrical energy in that case safe. When we designed industrial communication systems, field bus systems, back in the 1980s, 1990s, of course, the idea was to connect as many functionalities as possible, also safety critical functionalities. And by then, one of the big issues was, are field bus systems, are industrial communication systems safe? So these communication systems were seen mostly and regarded mostly under the safety aspect. And we all, I guess, still remember how difficult it was to make field bus systems fit for safety applications. So we added lots of redundancy, we added security layers, we added, safety layers, we introduced bus guardians, safety monitors, you name it. All with the aim of making these new communication systems ready for safety applications. And there are lots of standards associated with safety. Maybe one of the most comprehensive ones is the functional safety standard IEC 61508, but there are many more. Essentially for every application domain, there's lots of standards. For each machine type, there is a safety standard. Safety of machinery, there are also IEC standards, there are lots of ISO standards, so you name it, hundreds of them. But what about the security? We started looking into security, that was end of the last century, so around 96, 97, when we had the first ideas of connecting field bus systems to the internet. At that time, when we published at first, people said, okay, well, it's a nice academic exercise, but just dream on, nobody's ever going to connect an automation system, which is an island by definition, to the internet. I mean, how stupid could you be? Originally, nobody thought about doing that. Nobody thought about security, and the networks, the good old field bus systems, but also the internet, by the way, were designed without security in mind. When you look at the old RFCs of the internet, you see, well, yeah, security could be an issue, and something should be done about that, but let's get it going. And then we can consider security at a later point. Today we have this IT-OT convergence, which means connectivity. We have more and more IT devices actually on the OT level. We have standard computing platforms. PLCs are typically now ordinary PC platforms. And all of a sudden these cyber threats are becoming relevant, of course. What we suggested 25 years ago was to do something like a defense in depth solution. So you have onions, and within the onion layers, you can have a little bit more relaxed requirements, but at the borders, when you cross from one onion layer to the next, you need to introduce some access control, such as firewalls. That was our idea that was borrowed a little bit also from IT systems, where they did the same thing at the same time. And today this is the gold standard. So we have IEC 62443, which actually does that, and of course much more. So in this standard, we differentiate between zones, where we combine assets with the same security requirements, such as devices, complete communication systems, of course the network nodes, and conduits, which actually establish the connection between these zones. By providing access control, by providing firewalls, they are application specific, they are protocol specific, and you can combine that in many ways. We have network separation, which is still the ultimate goal, and we have barriers in between, such as, for instance, demilitarized zones, DMZs, that connect to the IT layers. Well, in practice, this is even more complex. We can have zones and conduits in parallel. They can be nested, all depending on the actual security requirements. There are different levels. This is one of an example that we looked at in our research. So this is kind of a best of what we have seen in our industry projects. We took all of these architectures and kind of combined them into this in this picture. Okay, but when we look at the security standards, there is not so much. We have the security standard that I just talked about, IEC 62443, and that's about it. There are a few OT-specific standards, but most cybersecurity standards are not tailored to OT, to operational technology. They are tailored to IT. There is a joint working group between ISO and IEC looking at information security, cybersecurity, and privacy protection. And recently, I saw that new standardization projects are being started in IEC that look more at the specific requirements of the OT level. That takes, of course, some time until these standardization activities will actually reach a conclusion, but we are now slowly starting. And now comes something completely different, which I would call the IoT challenge. Now, Internet of Things is very popular, and and also our industry partners are thinking about applying IoT concepts, IoT devices in their plants. Like, well, we could maybe use a webcam to just monitor, not doing really surveillance, but just monitor the systems and see what's going on there. Can it be possible? Can we do that? The problem with IoT is that IoT, the philosophy of IoT, requires that we have a flat hierarchy of devices. So they are not in this nice defense in depth scenario that we know from the IT and automation technology. That's flat. And all of them need an internet connection, and in many cases, the core functionality, or a big part of the core functionality, actually resides somewhere outside in the cloud. So you can maybe operate your IoT device without a cloud connection, without the internet connection, but then you're losing a substantial part of the functionality. Why? Well, IoT vendors actually want to have your data because this is where they make the money from. On the other hand, these IoT devices are cheap, they are easy to install, and they could be interesting for industrial use. Now, one of the issues here is, or the biggest issue, I'd say, is that when you install such an IoT device in your network, it somehow makes a connection to somewhere. It phones home to the vendor, to the cloud service, and does whatever it wants. It establishes a parallel communication channel. It bypasses security. In some cases, these devices even come with their own communication interfaces, so they use, for instance, mobile networks, and you have no control of that whatsoever. But actually, these IoT devices can bypass your security. And of course, the cloud-based servers can also be an interesting attack point. And then you have in these IoT devices lots of unneeded interfaces, lots of unneeded protocols that are there out of the box, or maybe some residuals from the development process, but they are not actually needed, but they are still accessible. And that feeds into the problem of IT-OT network convergence challenges. So we have these parallel network structures. Everything is heterogeneous. IoT devices bring their own connections. We have these parallel information flows. Even if we connect all the devices to the same network, the information flows can be out of our control. I will show you an example in a minute. Another thing here is for practical use, that's at least what we found from the discussions with our industry partners. Who is in charge of OT security? In many industries, it's the IT guys. But the IT guys normally don't understand automation. They don't understand the requirements of automation systems, such as never change a running system, don't do daily updates, the system has to be on 24/7. You can't shut it down just to replace some software. So there is a culture clash between these two departments. And I used to think that, well, I mean, this is just an urban legend, but people from big companies told me, yeah, that's true. They are fighting. I talk to OT people, to automation people. They are fighting with the IT guys because they simply don't understand what cybersecurity on the automation level actually means. An example, which is not from industrial automation, but from my smart home. I have a smart home. We remodeled that a couple of years ago, and it's now being used as a test bed for my students. I have to say for the best of my students, because I don't want everyone to mess with my setup. So I have PV on the roof, I have a battery storage in the cellar, I have some smart lighting and shading, and a heat pump because we wanted to get rid of the gas that we traditionally have in Vienna. All of these devices actually come with an IoT philosophy. All of these devices can be accessed nicely via some web interfaces that show me all the nice data. So I have the data for the battery storage, I have the data for the PV inverter, I have it for the smart lighting. only the heat pump is kind of old school. It uses Modbus, so it doesn't come with a web interface. So it's very convenient because I can look from here at a web interface of the PV inverter, and I immediately see what the weather in Vienna is. Now, there was one point in time where I missed data from the battery storage. I restarted the battery, and it didn't help. Data were still missing. I had a gap of 2 days, and well, as this is part of a research project, of course I cannot afford data being lost. So I wrote an email to the vendor of the battery, and they said, well, okay, yeah, we need to do an update. We need to do a software update for the battery management. Okay. Oh, I told them, well, fine. I mean, I have everything closed. I have a firewall that just shuts off everything. Will you send me a piece of code, a CD or a USB stick or whatever, so that I can upload that? They wrote back, no, we can do that online. Okay, next question from my side. Should I open a port somewhere in the firewall so you can access the battery? And they wrote back, no, we did it already. Okay, so what had happened? Well, it's evident. The battery sends all the data to the company so that I can access it from the cloud, and it opens an inside-out connection, and through that inside-out tunnel, the company can update the battery management system without me even noticing. I pulled up Wireshark and tried to find out where the packets flow. I had no clue, really. Either I was too stupid to operate Wireshark, or it was really so well hidden. And of course, this is that's a problem. Just imagine. I mean, it's good if they can do remote updates without me being involved. It's very convenient for the end user. But just imagine, this company has 20, 30,000 battery storages outside, from California to Australia, and the battery management system actually runs embedded Linux. By the way, they did not just do a simple software update, they did a firmware update. They flashed the hardware. And just imagine there is an employee which has just been sacked or is somehow, dissatisfied with the company. Such an employee could easily turn 30,000 really powerful devices into a classy botnet. And you wouldn't even notice it. And then you find yourself in a situation where you operate a device, where you own a device that is being used for some cyber attacks. The jury is still out on that, how that would actually be treated by court. But from a legal perspective, this is a tricky issue. Okay, well, what are the IoT security best practices? It might be tempting, but use with care. Still, for IoT, if possible, DM sets, network separation is the way to go, in my view. Change default passwords. Hardly anyone does it, but actually we should. User privileges should be installed or enabled or used if that is possible at all. In many IoT devices, every user, well, first of all, you have maybe just one user, and that user has admin rights. And even if you have the possibility to set up different users, they may still have admin rights. Try and deactivate unused ports, protocols, and services. And then comes the thing with the mutual dependencies. So far, we used to think about safety and security independently. So safety was taken care of by standards and people looking into that, doing the certification, and security was done the same, independently. But as a matter of fact, they are interconnected. What is good for security can be harmful for safety and vice versa. I will have an example later on. So actually we need to look at that together. It's even more complex if you look at all the different angles. The bottom line is if you do something which the safety people require you to do, you can actually open a big backdoor for cyber attacks. Now, standardization in this intersection between safety and security is still at its infancy. There are 2 technical reports by IEC, but that's it. There is something moving slowly, but there are no ready to use standards yet. I hope we will get some in the next few years, but that's something where people are just getting aware of the challenges that are there. Now, there are of course metrics to do risk evaluation. It all comes down to evaluate the risks, and in safety we know that we have the SIL, the safety integrity levels, where we do an analysis of the hazards, and there are lots of methodologies for that. So this is a given. There is something similar in the IEC 62443, which they call security levels. The security levels are actually defined according to what is needed to break into a system. So security level 1 is protection against coincidental violation. This is something that you could also read in the very, very early field bus standards and definitions, where they said, yeah, we have a hash code or we have a CRC, but this is essentially just against incidental typos, but not against real misuse. So that would be security level 1. And that goes down to security level 4, where you would actually have to withstand attacks from state actors. There are other vulnerability scoring systems that come more from the IT world, which are more intricate and more detailed. And you see on the right in that table the threat actors and their association with the security levels. Okay, so the assessment of safety and security risks is typically done independently. Safety assessment is clear. Security is something which is just starting, and this is the reason why we started that research project with TUEV. The problem here is mostly that these mutual dependencies fall through the cracks. People are not trained to look at that because they have their mindset, which is only safety or only security. So we need this combined integrated view on safety and security, and to a large extent this actually comes down to a modeling problem and to the question, how do we get the data and where do we get the data from? And this was the starting point for the SafeSec lab, which was a big PhD school between TÜV Austria and our university, with a goal to look at safety and OT security together, and to come up, ideally, that was what TÜV would have wanted, to come up with tools that can also be used for system certification in the end. We have 8 PhD positions. They are now gradually finishing their work. We had 20 plus faculty members from 3 departments at the university: mechanical engineering, informatics, and electrical engineering, where I am from. And of course, there were people from TÜV Austria involved. So that was actually a really, really nice project. I liked it a lot. We had leading Austrian companies as stakeholders. They were involved also once a year in workshops. And we did some testing, test beds at our TU pilot factory and the TÜV labs. Now, one of the use cases, we had other use cases as well. One of the use cases, because it's so obvious, are human-robot applications, because their security has an obvious safety impact. One of the PhD works was dealing with network monitoring and intrusion detection, and a big problem here in these human-robot collaboration applications is that you have, depending on how you set up the collaboration between the robot and the human, you have different safety requirements. And when you want to change this setting, even if you have the same robot, you need to do a recertification, which takes ages, which is extremely costly, and which limits the flexibility of the robot use. So that was a point that another PhD candidate looked into. But coming back to the modeling problem, it turned out, we were not so aware of that at the beginning, but it turned out that you have to collect lots of data about the devices, the configuration of the devices, the topology of the network, software versions, and all of that. So you have to extract from the existing installation lots of information, and you have to bring them into a structure. We looked into system descriptions using SysML and automation ML. We looked into using ontologies to describe all of these dependencies and all of these parameters. And based on that, the next step would be to define test cases and, of course, to check the adherence to requirements, because you have, from the standards, safety requirements, you have security requirements, and once you know the system, then you can check if the system in the current configuration actually meets these requirements. So putting things together in a big picture, you have lots of information. You have the standards, you have literature, you have domain expert knowledge, you have system descriptions. Part of them are just in written form, part of them are available electronically. You bring all of that together, put that would be the ultimate goal, into a huge ontology. And once you have that, you can start reasoning. You can start looking at the system and try to see if that really satisfies your requirements. And then you can give all of this information to the users, which can have different roles. They can be the system architects, they can be the certification engineers. That's something that should actually be done already during engineering. So not only when you have the system in place, but also while you are designing it. Requirements modeling is a crucial part, because there you can actually find these contradictions. So you could, for instance, then derive from the standards that a workstation shall always authenticate human users. On the other hand, a robot shall be shut down if someone presses the emergency stop button. How does that go together with the requirement that first you have to authenticate yourself? So you press the emergency button, and then the robot asks you, okay, can you please enter the password? And you don't the password, so you cannot execute the emergency procedure. But this is something that you have to find out. And we found that after this modeling. At the beginning, this inspection was just manual. Ideally, that should be automatic later on, but that of course requires that you have all the information available in electronic format. So, for instance, the safety rule says that the safety limits of a robot may not be changed. Full stop. Never change a running system. Security says, well, the sysadmin must have the possibility to update the system whenever needed. That's a conflict, right? So once you know that there is a conflict, you can resolve it. But first you have to be aware of it. Or, again here, the robot shall shut down if the emergency button is pressed, and the security people would say, well, from remote, don't touch a robot only if you're authenticated. And that just doesn't fit. Again, once you know, you can do something, but you have to know first. And these were actually requirements or conflicts of requirements that were not obvious by just looking at the system from a safety or security viewpoint. We can take it one step further. We can do threat modeling. There are databases about cyber threats out there that you can use. We did that. In a use case, we found something like 400 vulnerabilities, and then of course you can try and classify them and try to figure out which of them are relevant. Not so many, fortunately, are relevant. Lots of them are just, by coincidence. But again, you have a list to start from. And then you can try and put it all together. And this is what 4 of our PhD students then did. So starting from an installed system, you try and extract all the information. You scan the network, you read out the device data, you identify the topologies and the connections, you put that into an ontology, and then you identify the hazards and the threats. That would be the way to go. I mean, we are still not yet finished. The PhDs are more or less finished, but there is still lots of future research there. Oh, by the way, because everybody is using LLMs today, we are also using LLMs. LLMs can be used, and one of my PhD students did that. That was more like a Friday afternoon joke, but it led to a nice paper, actually. He said, well, why can't we use ChatGPT to just reason or help us doing the assessment? We asked ChatGPT, or we tell ChatGPT, well, there are security requirements, and please, Mr. ChatGPT, can you tell me if my system complies with these rules? So if you have all of that information in the system already, then you can use ChatGPT to actually process these requirements and let you tell you if it complies or not. And it worked. As I said, it was a Friday afternoon joke and was good enough for a paper. Okay, to start with something more practical, back to the cobot. We looked at the cobot at the beginning of the research project. We are in Austria, so skiing is very important. So the application was, we have a PhD student sitting at a robot and jointly mounting ski fixtures. And we wanted to look at the digital attack surface and to see where there is some need for action. And the results were that, well, there were a few unexpected IT vulnerabilities in the robot control system. So, for instance, we found that the robot can be switched off remotely without authentication. Well, from the security viewpoint, this is a no-no, of course. From the safety viewpoint, yeah, makes sense. But session tokens could be used forever. They were not invalidated. So the whole security concept didn't make a lot of sense. All users had admin rights. Yay, there's a classical one. Certificates valid for 30 years. Same thing, let's start and get the thing going, and this is why we just make certificates valid for an unlimited amount of time. HTTP responses did not include security headers. More severe, the server disclosed sensitive info about the software version. When you know that, well, you can tailor your attacks. And they used an outdated JavaScript library that was already at that time known to be very vulnerable. The bottom line for all of that can be fixed, of course, or should be fixed. The bottom line for us was robot developers are developing robots. They are not IT specialists, not necessarily. And this is what should show the whole problem. Automation people are good at process control. They are good at control engineering. They are good at developing robots, sensors, controlling processes, they are not necessarily IT guys, and we should simply respect it. So this is why we actually need to bring these two expertise fields together, because there is no one size fits all, and we cannot expect that everybody knows everything. And that's what remains actually a challenge, and what we can do with our tools is just to help people to get more aware about these security issues in operational technology. So I would like to acknowledge the team, and there are a few more that were not on the picture here. And with that, I hope I somehow stick to the deadline. Thank you so much.
Okay, thank you, Tilo, for that very nice and inspiring presentation. So it sounds like we still have a little bit of work to do also in our academic projects. So we do have time for some questions, if you have any in the audience.
I can ask.
Okay, let's use this.
Thank you, Tilo. I think it was extremely nice. So my question is about using automation ML and SysML for modeling and analysis. We have just a little bit experience with that, and it seems there is also extension of that for the security. It's SecML or SysML. But I just want to hear your experience on both modeling and what kind of analysis you can get from that, or if it's something interesting to continue working on that from the research perspective.
Yeah, we looked into these modeling languages and found that automation ML is very, very comprehensive and very much tailored to automation applications. SysML is maybe more, futuristic, is more complex, has more possibilities. This is why we lately switched to SysML, because you can do more. For the details, I would really have to refer you to the 4 PhD students who did all of that. But the impression lately was that SysML is maybe more the way to go, because automation ML was derived from XML in a sense, and it somehow still reflects the spirit of the 1990s, early 2000s. SysML, especially SysML version 2, is more modern and allows more.
Excellent, thank you. I think I turned it off accidentally, but now it's on.
Okay. Boris.
Thank you, Peter, for the very nice presentation. So my question is, you mentioned the standards, there's like the safety standards and then the security requirements, and sometimes you have contradiction. How much is this dependent, what you have found, how much was dependent on the use cases that you have used? Is it like, can you do like a general work, or it's like more use case dependent? And also looking at standards, sometimes it's up to how you interpret those standards. So sometimes they are not very, very specific, so it's very general.
Right. So second question first. This is something which I had on my slides, but I didn't talk about it. Especially in the safety standard area, because there are so many, you always need these skilled people who can tell you, well, let's say I have a robot here, and which standard does apply? So you go to TUEV, and then you have 5 people sitting around the table, and they come up with 7 different opinions. Like, well, in this case, I would apply that standard. But no, if there is a human involved, then we need to apply that. So even in the certification community, it's not always clear what standard applies. In the security domain, it's I'd say it's easier, but definitely all of that applies on the actual use case, how the system is set up. So it's and this is what makes the whole thing so difficult. Of course, you have standards. They try to be reasonably generic. And then comes the question, okay, does it apply or does it not apply? For the security thing, if a system is vulnerable, it's vulnerable, full stop. For the standard, for the safety part, it seems to be more tricky.
When you were talking about the contradictory requirements, I always wonder whether that is inherent to security itself, in the sense that there's no way that you can avoid it completely. Because if you make something completely secure, it will be at some point against ourselves, right?
Mm-hmm.
So how can this be solved?
Don't connect it to the internet. I mean, air gapping is.
You want that, right?
No, well, air gapping is still. Yeah, of course you want it because it's convenient. Yeah, the question is, do you want to sacrifice convenience or not? Of course, some time ago, I read about an irrigation computer. I don't want to say from which company. That was operational only if it was connected to the internet, because it was operated via the cloud. So if the internet connection is not available, you can't irrigate your garden. Does that make sense? No, of course it doesn't. So many of these IoT devices are cool because they give you all these nice graphs and apps. But if you want to be on the secure side, not on the safe side, then you actually have to shut them down. You have to disconnect from the internet. I don't see any alternative if you really want to be secure.
Which you don't, clearly, right?
Yeah, well, again, it's how convenient do we want to be, or how convenient do we want things to be?
Thank you for the nice talk. So we have been working on safety cases and a little bit on security cases. So do you think that this kind of work, we are coming to another end, like certification so if one could connect these things in kind of harmonization standards, because if you do something for the safety, you actually cover many things for the security, and then finding the leftovers, do you think that will be a good kind of approach? Is one question. And the other thing is about, I hear a lot about this AAS, Asset Administration Shell, and that kind of, are you looking into that? Something is it really popular these days?
AAS, yeah, I did skip that, but yes, as a matter of fact, the AAS would be the place to actually put all these safety and security requirements in, because this is where you kind of create a digital twin of the actual automation device. And here you could actually place all these requirements, and not only requirements, also the functions, and so that would be the way to go. And one of my students actually started looking into the AAS as the way, or as the place of hosting all of these functionalities. In the end, he got a little bit diverted by the need of collecting the data and doing LLMs and all of that. But yes, AAS would be the place. And what was the first question?
It's a comment so it's mostly on the security, safety, harmonization thing. And coming back from the certification side, cases, safety case, security case, providing evidences for
Yeah, that would be. I mean, yeah, like you do the safety certification. Yeah, I don't know if it's safety cases, HACCP or whatever you do. You could do something similar on the security side as well, but it's still not so developed yet.
So I have a question coming from the control engineering side. I mean, if you look at your presentation, it looks very, very nice, and it is also, you can see similar trends in, for example, in the automotive domain, when people didn't start to connect stuff to the cloud necessarily, but maybe you connected everything to the infotainment system, and then you bumped
the same thing. Yeah.
What can go wrong? But my question is, it's kind of a dual question. Is what can people coming from the OT part do in terms of improving the security situation? maybe in terms of designing systems to be more secure from the design perspective. And on the other hand, would it make sense to start creating, from an educational perspective, a professional figure that can sort of understand both domains, or should we keep like the two domains very separate, like people dealing with control and people dealing with IT, and then we don't talk to each other, we just rely on some interface?
No, of course not. Yeah, I remember when I worked together with a colleague from the Control Institute 20 years back, and we published one paper on network-based control. The old school control engineers would tell me, you don't mess with the control loop. I mean, control loop over a network, don't do it. You can maybe change the set points via the network, but closing a control loop through the network this is never going to happen. This is never going to work. And it's similar here. Yeah, of course, I'm teaching my students these automation things and these safety aspects, but of course also the security thing. People have to understand that, definitely. Because if you never heard that, you don't think about it. So education-wise, definitely we have educate people to know both sides. They need not be specialists, but they need to be aware of the problems. Regarding what can we as control engineers or automation engineers do to improve security? Well, again, try to avoid that everything is in a flat network. I still think that this concept of defense in depth is good, and that we should keep functionality as local as possible.
If we have time.
Yeah, we.
Yes. So one more question, because you also mentioned about these clashes, culture clash, and we recently also had this experience of implementing soft PLC in one of the partners that we work. And the first thing that, so there were many people, also IT and maintenance, and the first thing was that who is responsible for that? Because IT people didn't want to do that because it's a remote and they are not going to, and then the maintenance people also didn't want to take the responsibility. So did you have such experience, and how did you manage to convince them or find a solution for that case?
Of course, it's always about responsibility. If something goes wrong, who is liable? Who gets his head cut off? That's always the question. And if I can just push everything away from my desk, I'm on the safe side. Or the secure side, depending on the way of looking at it. The stories that I have been told from our industry partners are the same. Typically, as university, I just step aside and say, well, yeah, that's very interesting, and maybe you should come up with solutions. But one partner now told us that OT security is now being taken care of by OT people. So originally it was clear that it had to be IT, because security is IT automatically. And now they established more competence in the automation department, and that has improved things.
So hello Thibaut, thank you for the presentation. This is quite similar to what I've been working on in my PhD, but I have another question from kind of another angle maybe. So there are a lot of regulation initiatives ongoing, specifically from EU, but also from other states and organizations. Apparently, we who develop products in this area are not really good at implementing or adding this functionality. Will the regulations save us? Do you think that is the case? For example, the consumer or the cybersecurity CRA, will it save us to some extent or not?
Oh, they will not really save us. They will make things more complicated. because all of a sudden with this, I mean, I'm not even talking about the AI Act. Yeah? This is yet another thing. But I mean, all of a sudden, as I say, as a whiteware producer, say you do a smart fridge, you all of a sudden find yourself in a position where you have to guarantee that this fridge is actually secure. And here again, I mean, you are a fridge producer and you just add some nice Raspberry Pi or something that just establish some internet connectivity. And all of a sudden, you have to comply with all these new regulations. So people are really scared and they don't know what to do. I remember we had a workshop 2 years ago when all of this was brand new and nobody could tell the vendors what they should do with it. Not much has happened since, so I'm not sure how this is actually being executed in practice. I guess the regulations tend to overshoot a little bit at the beginning, so you try to make things extremely safe, extremely secure, extremely high barriers. And then, when it's time to start implementing things, you realize that you can't do it that way. And I think we are at the moment in this phase. But no, they won't save us. Surely not. Because a hacker doesn't care about regulations.
Okay. All right. So we're approaching the end. But I've been thinking during this presentation about, so I'm very much that engineer that make the thing work without considering the maybe even safety or, and in particular, not security. So, but I'm thinking a lot of the technology development, I would say the new things are developed for consumer markets, and we tend to use the technology for a while, and then we throw it away and we buy a new thing. Looking at industrial systems, process control, big installations and so on, these systems are in place for many years. They could be maybe a decade or even decades. And the way you design your system, you have a certain architecture, you have a certain amount of, let's say, resources, computational capabilities and so on. And you have solutions for the, let's say, security threats at the time. But then the decades pass, or the years pass. I mean, we need to be able to do these types of updates and so on. So what is your take on that?
Why are there so many Windows XP computers still out there? That's exactly the reason. Yeah, we need to do these updates sooner or later, but I mean, plant operators are very reluctant to do it because with each new update, I mean, there's two things. One is the functionality. You don't know how the system reacts after the update, and then if you are entering safety critical systems, you might need to do a recertification. You can't just do an update. Once you touch a bit, you need to recertify the whole thing. Unless you have safety PLCs where you can, in the user space, do updates of the program. But this adds to the complexity. And this is why I think that controlling the access from the outside is maybe the easier solution. Because there you can do something. You can update your firewalls because you don't mess with the core functionality of the system. Once everything's connected to a flat network, then you are doomed. So I think that system separation, network separation is still the way to go. And this is why I'm a little bit, and we might talk about that in the afternoon, this is why I'm a little bit skeptical about connecting everything to one single network.
Okay, so thank you very much for this inspirational talk and very good discussions and comments by the audience. I think we have a lot of work to do still in this let's say area of development and research. So thanks a lot, Tilo.
Thank you.